Okay, so let's look at the chemical symbols that the periodic table has in them and the important information on them. All right, so in this particular case, I'm going to move this up here. Okay, so I can see it better. All right, so if you'll notice, each element has a chemical symbol. So there are two. It can be one letter or two letters, one letter or more, but always the first letter has to be capital. Didn't spell that right, sorry. So notice that the XE, that's a capital X, and then this small lowercase e, that stands for the element xenon, right? So it always is a capital letter, and if it has a second or third letter, it's always small, okay? So what people get mixed up with is capital C and capital O are two elements, carbon and oxygen, but there is an element that's got capital O, capital C, and little o, which stands for the element cobalt. Okay, so these are two, because they're two capitals, that represents carbon and oxygen. Okay. Carbon and oxygen. Okay. So let's look at the information, the numbers. Okay, so if the number here, 54, is the smaller number. Sometimes they put it on the bottom, sometimes they put it on the top, is the number of protons. Number of protons in the nucleus. The number down here, and we're going to round this to 131, is the number of protons plus the number of neutrons. Okay, so we already know that there are 54 protons, so I'm going to subtract 54 protons from this. This is a 2, this is 11, this is 7. I'm going to make this a 12, 7, and 5. So 77 neutrons. So 54 subtract from 131 gives us the neutrons. Let's look at carbon. The atomic number tells you the number of protons. So as I said, carbon, capital C, only has one letter. So six protons. I'm just going to put the letter P, and it's a positive charge, right? And we're going to round this off to 12. So I'm going to subtract, and this is the atomic mass. Atomic mass. The smaller number is the atomic number. Okay, so the atomic mass is the number of protons plus neutrons. So we're going to subtract that. So it has 6 protons, and 6 neutrons. That equals to 12. All right, the atomic symbol is abbreviation for the element's name. Some are harder than others because they use a Latin name. Neon. Let's take a look at neon looking at the numbers here. Okay, so neon, capital N-E. This is the number of protons, 10. Okay, we're going to round this to 20. So 20 minus 10 protons equals 10 neutrons. So this is called the atomic mass. Because that's the weight, the total weight of the protons and the neutrons. This is just the atomic number. Which is the number of protons. Okay, so the atomic mass tells you how much the atom weighs, the number of protons plus the number of neutrons. Let's do this one together. All right. So if I ask you the atomic number question mark, you would say it's 20 protons. Round this to 40, subtract the 20 protons, got the O there, gives you 20 neutrons. And the 20 neutrons and the number 40 is called the atomic mass. So how do you put this information together into one table? Well, Dmitry Mendeleev, a scientist in 1869, arranged all the elements known at the time into a table. Although it's expanded, some basic principles are still used today. Let's look at some more at what we've learned about the periodic table. All right, there are 3 types. Okay, so the metals are in the pink here. All these are metals, so the majority of these are metals. The metalloids are the green, and the blue ones, so even the hydrogen over there, are the nonmetals. So these are gases and liquids. These are the hard things, those are the metals. And the metalloids are in between. Metals have similar properties. They're shiny, solid, and good conductors of electricity and heat. Metals are ductile, which means that they can be pulled into thin wires. Metals are malleable, means that they can be hammered into thin sheet. Think about aluminum foil. It's a metal, but it's really very thin. and you can fold it easy. Nonmetals are just the opposites of metals. They're kind of crystals in some respects, or liquids. They're not very ductile, which means that they can't stretch them out, and not malleable. You can't hammer them into shapes. Nonmetals are very good conductors, are not very good conductors. In fact, they often used as insulators. So this is an electric fence, and this plastic piece right there is an insulator, so it doesn't put the electricity in the pole. So that means the metalloids are somewhere in between. So here's the in between here. Metalloids tend to be partially conductive. It makes them valuable when creating computers. Metalloids are solid or liquid and usually are ductile and malleable. Metalloids can be solid, liquid, and usually are ductile and malleable. Lastly, let's look at a couple cool things about periodic table. The far right group of the table is called the noble gases, right? And they are unreactive, so that means that they don't combine with anything else much. Noble gases are the most stable of all elements, and their outer shell is completely full of electrons. At the top of the table are two special elements, hydrogen and helium. Hydrogen is the only element without a neutron. It has only one proton and one electron. It's also the most common element found in the universe. Helium is grouped with the noble gases. It only has 2 electrons in its outer shell, but it's incredibly stable.